Okay, robot walk. And it says a robot is standing at the 0, 0 point of the Cartesian plane. And it's oriented towards the vertical y-axis in the direction of increasingly y values. In other words, it's facing up or north. The robot executes several commands, each of which is a single positive integer. When the robot is giving a positive integer k, it moves k squares forward and then turns 90 degrees clockwise. So, okay, if you give it k, it will move k squares and then turn to the right one block, I guess. The commands are such that both of the robot's coordinates stay non-negative. Okay, so it won't go farther than the first quadrant, I guess. The commands, your task is to determine if there's a square that the robot visits at least twice after executing all the commands. Oh. Square that the robot visits at least twice. Okay. So you start at 0, 0 and go 4. 1, 2, 3, 4, and then turns to the right. And then you go 4 again. 1, 2, 3, 4, and then turns to the right, which is now facing down. And you go 3, 1, 2, 3, and then turns to the right, which is now going to go to the left. 1, 2, 1, 2, 1, 2, 3. Okay. Okay, I know the path. I can follow the path now. The point 4, 3 is visited twice. So the answer is true. Point 4, 3. 4, 3 here is where it kind of intersects, right? So it went there twice. Okay. An array of positive integers is the input, and each number will represent a command. Okay. So I could give it a shot. I don't know if I if I will be able to figure it out, but let's see. So let's see. We would be recording the coordinates, I think, and then matching or looking for repeated values for that. So I think I can keep these as strings as of the, like, what was the actual point that the robot visited, right? So what does it mean to have it go forward and then turn right every time? What it means is that we have a change in direction. So something like direction would be +1. So it's going up. It's going to be, it's going to go up. So let's say, let's the direction up, let right. I don't know what I'm doing, but let's say that now I am going to, wait, no. I'm not moving there, I'm moving here. and then I'm not moving on, I'm moving to the right, but not. So then down. Will this help me at all? I'm not. I'm moving this way, but not that way. And then up, right, down, left. I am moving. Oh wait. Oh, come on. I'm not moving here, but moving here. And left, I am moving here and not here, I think. So no movement on the x-axis, but one. So the positive way means up, right? Right means I am moving to one positive value to the right and none on the y. Down means none on the x and down on the right, on the y, and then left on the x, none on the y, I think. Will this help me at all? I have no idea. Maybe if I had like these could be constants. It doesn't really matter, I guess, but let's just call them constants, and then we call this movements or something. So the next movement after you go right is, after you end up walking right, the following movement will always be to go down. If you were coming from moving left, the only possible other option that you can go is moving up, some kind of like that, right? I think. So, knowing that, I can now take the array and then take the command and I can then since we started the 0, 0, the first movement is up every single time, right? So what I can do is calculate the new position based on this information, and I can say like my point is going to be command so my command is going to be something like create a cycle where, let's say, we have this And so I can only go one, let's say 0, 1, 2, or 3, I think. So this will be 0. What I'm trying to say is I'm gonna go and fill in. So I'm at, okay, I'm gonna need to know where I am at right now. X is gonna be 0, or sorry, this is a value that will change 0. And then I can do I can do 0, 1, 2, 3. So I can do 4 times. Oh wait, no, but I need to keep track of every single point. I need to keep track of every single point. I need to have a record of you visited, kind of like this. You visited 0, 0, and then 0, 1, 0, 2, and 0, 3. So at this point we are at here 0, 0, 0, 1, 0, 2, 0, 3. One, 2, 3, and 4. So I need to go from here. So this is kind of like my default value. And then I start there. That's my starting position. And then I go 0, 4. And then 4 means I need to go right, which means I need to take this 4 times and have this be 0, 4, and then 1, 4, because I'm going right. So I add this and keep this unchanged. Something like that. So 1, 4, 2, 4. Wait. 2, 4. 3, 4. And 4, 4. And then at that point I end and start with the next one. Okay, I kind of have an idea, but I'm not sure if I am going to make it work. Okay, so this will keep track of my position, right? And then these movements will help me I'm wondering if there's another structure that I can use here instead. Like something that tells me I don't change this. Yeah, okay. I could sum those values maybe. So we're good there, I think. All right. I'm gonna do this so I can see better because it's a lot of code now. Okay. So and I will be the number of times I need to move, I think. While I is less than the number of times I need to move. So A. So I was fine there, I guess. So here. Let's do moves, and then I at I0 while I wasn't the amount of moves I think I need to. Okay, so let's do that facing equals. Okay, so I'm gonna need the index at which I am standing on right now, and I need to do the modulus between my index and 3. 0, 1, 2, 3, I think. So one thing I need to check, well, let's do that real quick here, is say for example that I have the index 0, and then I want a residue between 0 and 3. And then if I go to index 1, and then so on and so forth, until I reach index 3, at that point I should go back to 0, is that it? So if I'm up, right, down, left, no, I think I should do it against 4. And then I would go, let's try again. I don't know if this makes sense at all to what I'm trying to do, but let's do it against 4. 1, 2, 3, 4, and then 5. 5 goes back to 1 because that's what is going to allow me to go back in circles here, if that makes sense. But I don't think, okay, so I'm going up, and then I'm going right, I'm going down, I'm going left, I'm going left, so up, right, down, left. Oh yeah, and the next one will be 0, so I'm going to be up again. Yep, and then I'm going to be right again, and so on and so forth. So yeah, I need to get the residue or the modulus at 4, not 3. At this point I know where I am facing. I am facing movements. Let's probably call this direction, right? So I'm going either of those directions, and I'm facing one of those directions, Yeah, I think this makes sense. Next, let's say that, yeah, that I need to move toward where I'm facing. So I need to make x equals plus equals direction or facing at 0, and y plus equals facing at 1, right? And then I can do let's do trail or path or something. Path const path equals an empty string. Wait, no, it's gonna be this guy here, maybe, because this is one I want to fill in, right? This guy here. So let's do, yeah, let's do path dot push, and we're gonna do template letter here. We're gonna do a template literal here with x, comma, and y, I think. So I'm gonna be pushing those values here. Okay, and then I needs to move forward. So I is 0, and then moves is the amount of moves I need to do here. So I will go, if I'm facing 0, that will be 0. And then this guy will be facing y, which is 0 plus 1. I think that's it. As for kind of like the first movement, and then this will change. And yeah, I need to put this within the cycle here, or the loop. I think. Let's log the path and see what we get there. I am a little bit not so. Okay, let's try this. Yeah. Identifier I has been already declared. What? What did I do? Oh yes. I don't need that index. Okay. So I will have something like 443223. 443223. That will yield 0 0. I need to unshift this value. 0 1, and then 0 2. Oh no, where's 0 2? No. 0 1 1 1 1 0 0 0 0 1 1 1. Oh, this is just taking this value and putting it all over again. That's not what I wanted. Okay, what am I doing wrong? I don't, and then 4 2. A for each. While I is less than or equal to moves. No, I need to keep the 0 1 0 2 0 3 0 4. So let's say moves is just the one value here, right? So 4 times, which is here gonna be 6 times. So the time 1. No, I do need this to be 0 so I can access this index of direction here. And I just need to do it an n number of times. So okay, let's not do that right now. And let's do this, and let's do console.log facing instead there. Okay. So because I'm updating I should not be moving I until the next time. Right. So it's not I, but it's facing direction, current direction. So I'm going to do current direction equals this guy here, and then try that. Now I'm not updating the direction because I'm doing it out of the loop. All right. Wait. Shoot. I'm just doing the same thing. So current direction. Is the direction independent from? I think it is. Yes. Okay. So the direction is independent. J equals 0 here, and then J plus plus to update that direction, right? So we have 1 2 3 4, which is this, and then 4 others, 1 2 3 4, which is this, and we have 3 which is 1 2 3, and then 2, and another 2, and 3 more. Okay, great. Sure thing. Alrighty, so we're kind of back on track. So let's say now it should be 0 1 is up, and then 1 0 is right, and then 0 minus 1 -1 0, and then the next one should be back at this place. All right, so we are getting somewhere. Okay, so let's now go back and print the path, see what that gives us. And if it looks any closer to what I have here, then we are good to go. So a 0 0, so path will be actually 0 0 at first, and then I push stuff. 0 1 0 2 0 3 0 4 1 4, we're here. 2 4 3 4 4 4 2 4 3 4 4 4, and then 4 3, and then all we need to do is check if we have duplicates in here. So the quickest way to do this would be, maybe, I am thinking real quick, that we could probably do something like, oh, I'm trying to comment this out here. We could probably do something like path or unique points. It's going to be a new set based on our path array. And then we can create another array. Let's just call it array, or let's do array unique or something. Sorry, array dot from our unique points. And we will return whether array unique dot length is the same as unique. No, sorry, as a path dot length. If it's the same, sorry, this is a comparison. If it's the same, then they don't touch, and the idea is to get a hold of whether they touch or visits twice. So if they are not the same length, wait, if they are the same length, they don't visit twice. If they are different lengths, then they visit twice. Right? I think so. So one thing that I should probably be mindful of is that this could be a very large number. Let's see. No, but it's not the... Yeah, it's the value. It's how far into the quadrant can it go, I think. So I don't think there should be an issue here. So yeah, let's recap real quick here. What I'm trying to do is determine what the different directions are by saying, so I'm moving on this axis or not. In this case, I'm going up, which means X value won't change, but Y value will change in the kind of like the positive way. So it's adding 1 each time it moves up, and then same thing for each one, right? To the right, it goes increasing the X value, but not the Y, decreasing the Y value when we're going down, and decreasing the X value when we're going left, and the other coordinates are not moving. The other directions, what do you call those, are not moving. This is a partial, so I don't have the entire path mapped out here, But that was the idea, to have an array that will give me the position of this direction. So let me try that again. The directions, I just named them to be more specific, more explicit about what I was trying to do. And we will just have these arrays within the direction array. These will let me know where the point is at that moment, and the path starts at 0, 0, right? So this path is the one that's going to be filled in with values like so. And then what we do here, the kind of like the interesting part, is we take the moves array, the movements. So we take the movements. So I think we could, yeah, let's just call it moves. Number of moves, let's call it that. So this is the array that tells us 4 moves, in this case up, then 4 right, 3 down, 2 left, 2 up, and 3 right. We ended up at the right direction. So that's the one. And then we have this j variable out here, which is going to be keeping track of where the current direction is. It's going to help us do that. And for each time we move within the movements array here, the one that's provided here, that j value will be updated over here. When that happens, then the next time around it will be calculated the remainder of that, so that we move from here to here to here to here and back, and so on and so forth, however many times we need. So that's what's going to tell us what the current direction is, and we just take that from here and we put it in facing, and we calculate the x position as well as the y position by summing or adding up the value. So I'm going to be adding 0, adding 1, adding -1, which effectively is just decreasing 1 to the x value, or to, in this case, the y value, the x here. And in that case, we can add this kind of little format with x comma y. Could probably do without the comma value, but it was nice to see the printed value when testing. And yeah, this could have very well be like a for loop as well. It doesn't really matter. And the next part is then to determine whether the points are repeating in the path array, right? So the quickest way I figured out that was, if we create a path or a set out of the path, that will remove all the duplicates, and then we put it back into an array, and then we check its length. If that's the exact same length of the original path, that means that the points didn't repeat, because we got the same exact length. And that's the way to figure it out. I kind of think a couple other ways, but I'll wait until we see the other people's solutions. Something I didn't do was try with the real values, and we'll see if probably my solution is taking too much memory. Oh. Yeah, it timed out because I'm using too much memory, or too much space, or something similar to that, which is fine. We need now to to improve the performance of this, I think, because otherwise, some bad things can happen. Alrighty. Oh, so this is what they were talking about. that the number of movements could be real long, which means that probably my array here will be extra large, and I won't be able to just keep that everything in memory. It's probably that's it. All right. So I don't know what we could do in that case. There's probably something to do with the fact that you already went through. You already went through that, you know, y axis maybe. So what we could do is probably, no, that would be too big. If we had like an index of, so we passed through this axis once, and then twice, 3 times here. So once, well, 1, 2, 3 times that I updated that value. I don't know. This is an interesting problem now that I don't have the unlimited memory, or unlimited space here. Basic tests run fine. Even if I had 34,241 moves, it does know that it goes up and then right and then down, all that. But that's because, wait, how large is that array then? That's an interesting, I think we can start there. Wait, but I only want that test here. Where's my log? Here. So the length of that array is 60,017 points. Okay. But when I go and attempt the larger ones, I'm not even gonna get the $36,000. So I guess I could walk that array. If I am able to walk that array, let's just keep a few of these as basic tests. Hi. So this guy, that's gonna be my basic test now. Oh, and I don't know if it's false or true, but that's okay. And then let's keep, I don't know which other one. Oh, I need to see the rest of it. Okay, thank you. Let's keep this one's really large. That one's real large. Okay. So test equals robot walk. And I don't know if this is false or true, but it's okay. What I need to do though is to remove this here and then test. What? Assert that this equals robot walk at that. Wait, what am I missing? False. Yeah, this is not false. Wait, what? Okay, let's try again. Yeah, I blew it. 23. What is going on? Oh, I shouldn't be ending that there, I don't think. Yeah, and then the function ends in that. Oh, come on. What did I do wrong? So I removed that. That should be there. And I think I should not have that there. There you go. I think this works now. Okay. Yeah, true to equal false. So I guess this is supposed to be true. And then this one was supposed to be false. I don't know. But the problem is that these work. So this is not helpful. Okay. Having this in mind, let's see if we can, if there's not an issue with the amount of data that we're putting in the path, it might be with the fact that we're doing this, creating yet another structure here for checking. So let's comment all of this out and walk through the path itself, right? So one trick I recently learned was to get the unique elements in an array. So let's see if I can put it in other words here. So let's say I have my array which has 1, 2, 3, 4, 1, 2, right? And that I wanted to filter let's do let uniques, and let's just get a hold of whatever we're not repeating. So if my value was not found in that, sorry, this would be dupes instead. So it's either way. So duplicates would be this, and then uniques will instead be the ones where I actually find them, right? So we can either look for any of those and say if dupes is like it has a length, right? So let's copy this part here. And then do return dupes.length. And we're converting this into a boolean by doing that, and saying if there's any value that will be truthy, which returns true, and then dupes will be the amount of dupes that we actually have. Not the amount, but rather the duplicate points that we have. Arrays not developed. Sorry. So instead of R here, we need to do path, right? Which is now gonna take a long time, which is not good. It timed out. Yeah, I figured I would be. Okay. What we could also do instead of this. Okay, let's do it in a for loop, maybe. Via for x equals 0, x less than. Okay, let's do while x path dot length and x plus plus, and then const to found false. If that happens, or dupe found. X plus plus, and then path x index of. So let's do dupe found is going to be index of x equals path dot last index of x, I think. So if this makes sense, I'm trying to see whether, let's do this here. I'm trying to see whether in my path there's the same idea up here, right? So if we are not at the same index when you find this or this coordinate, this point that I'm looking at. So if I take this, and then there's a different last index of than the one I have, then dupe was found. Otherwise, it won't be until I reach the end of the array, or I actually did find a dupe, I think. And then we're gonna return whether we found it or not. Let's see if that does anything. Of course, I did something wrong. This is still taking too long. I can't do it this way though, then. Okay. This is very interesting. Wait. So I thought the difficult part was gonna be to determine the path to take. I guess it wasn't. So what was interesting to me was that this was actually running well. It did well on memory and space consumption. But when I bring it in to this is very interesting. Where else can I save? Wait, so I just passed one? And then it broke? Oh no. Alright, so I guess this is the one that's failing. I don't know. Okay. Let's paste that. And then try and copy this guy here. And then update the array value in here. Let's comment these out and run the test. Unexpected end of input. From whom? Ooh. Oh yeah. I didn't have to do this here. Sorry. It did work for this basic test. Okay, I am officially puzzled. I don't want to spend much more time in this. I think if I take a break, maybe I can see what happened. This doesn't look good on me though, to not be able to figure out what the issue is, but I'm sure that if I take some more time and think about things, I will get it. It's just not my priority right now. So I know what to look for next, performance-wise and things like that. So I'll take care of that when I solve other exercises. So I'm just gonna leave it at that, and what I'll do is unlock the solutions, I guess. So just gonna save it somewhere and I'll be back.